So our project was analyzing racial and gender bias within stable diffusion text-to-image models.
In terms of the big picture for our research project, our main concern was that images generated by artificial intelligence may discriminate against certain demographics, such as women and people of color. So for our research project, we focused on how stable diffusion outputs reveal an underlying racial or gender bias with respect to various prompts. If you look to the right, you can see some of the images generated by Stable Diffusion XL, which is the latent diffusion text-to-image model that we used in our research project. Essentially, all you have to do is input a given prompt, and Stable Diffusion will return an image as an output with respect to how it understands whatever you inputted. So previous work mainly focused on how professions and occupations related to gender or race, while we examined bias in both profession-based and action-based prompts.
So word embedding models have previously tended to display bias within gender, ethnicity, or race in relation to certain topics. So for example, if you type out, "she is a doctor," and it autocorrects to "he is a doctor." And these biases can also be found in text-to-image models like Stable Diffusion, where you enter text and it outputs an image. So image models tend to overrepresent images associated with whiteness and masculinity, such as the image to the right. And methods to remove bias exist, but researchers caution against the removal of bias because most efforts don't end up removing deeply rooted bias, and the model performance decreases significantly. So biased images reinforce common stereotypes, influencing people's beliefs, which is why this is a problem. And AI is only accelerating, especially in the last year, and expanding into various sectors of the world, such as business, healthcare, and just people's everyday use. So an example of the bias is around 30% of chief executives were women in the US in 2022, and 70% were men. But through the images that we generated through Stable Diffusion, only 5% were women and 95% were men. So to the right is one of the images that was generated by Stable Diffusion.
Our project had three main goals. Our first goal was to create prompts that allowed the model enough freedom to make its own inferences and exhibit how an underlying bias has an effect on the images it produces. Second, we wanted to generate our images through Stable Diffusion XL and classify by gender and race using OpenFlamingo, which is a well-known model for image captioning. And our last goal is to analyze data and consider how real-life statistics and demographics influence the outcomes of our images.
To generate our images, we used the Equity Evaluation Corpus dataset to create our prompts to feed into the Stable Diffusion model so it can make its own assumptions and exhibit its bias. This dataset was created to tease models into revealing bias through a collection of sentences and phrases that have traditionally been known to exhibit bias within models. Through this dataset, we generated over 2,000 images, with 1,000 images for professional prompts and 1,000 images for action-based prompts. Profession prompts were created by simply inputting the name of the job into Stable Diffusion. So an example of a profession prompt would be generate an image of a nurse or generate an image of a CEO, while action-based prompts were created by inputting actions which have the greatest potential for bias into Stable Diffusion. An example prompt would be generate an image of a person getting arrested. We generated over 20 images for each prompt and used tags in each prompt, which allowed Stable Diffusion to generate images which showcased the face of the person performing the profession or action, which made it easier for us to detect the race of the individual's face, helping us in determining bias in our images. So to the left, we see an image of a carpenter before adding tags. And to the right, we see an image of a carpenter after the use of tags in our prompt.
So now we needed a way to identify the race and gender of the people in these images without any human error or bias. So we used OpenFlamingo, which is an image-to-text model that accurately helped us do this. So we can see how OpenFlamingo works, or I guess how the code would work on the right in this flowchart. For an example, we have an image of a nurse here, which is one of the images we generated. And then we ran it through OpenFlamingo using this prompt on the second bullet point, which is to identify the race and gender of the person. And we gave it 5 options, which were white, Black, Asian, Pacific Islander, and American Indian. These 5 options are used by the United States Bureau of Census, which collects racial data. So we thought it'd be best to use them here too. And then once you ran the image through OpenFlamingo, it would return us with the race and gender of the person. So as we see here, in this bottom part of the flowchart, it just returns that. And then we collected all of that into a data set, which would help us identify trends and biases by organizing all of the information that we had gathered.
We found that no images presented any blatant racist stereotypes, and on average, white was a dominant classification, taking up about 75% of the results. Asian was also dominant, but was marginally less common except for the prompts judge, CEO, engineer, and electrical engineer. Black and Indigenous American or American Indian were significantly less common, with outliers in police officer and firefighter. Pacific Islander, while included in the classifier prompt, was not found in any of our results. And because our sample size was 20 images per prompt, any value below 5% was considered negligible or inconsistent. Like our race calculations, no blatant stereotypes were exhibited for gender, but there was a clear dominance with the male gender, with most occupations with more than 50% male. Conversely, women did not dominate many occupations, with marginally fewer women-inclusive results. However, it is important to note that with our occupation results overall, the dominating gender or race depends on our prompts, which may have been more male-leaning occupations to compare them with real-life data.
So for the action prompts, we see a lot of similar trends to the occupation prompts. First of all, there's a vast majority of people in the images that were white, as you can see on the graph represented by the blue. And then some other specific trends were that Asian people were generated in images that had to do with actions related to like intelligence or academia. For example, going to school, doing math, or playing an instrument. And then the only prompt that Black people are generated a lot in was playing basketball, which is an interesting trend. And then the other 2 races, which were Indigenous American and Pacific Islander, were not generated as often as the other 3 races. And were pretty much just outliers in many cases. So here again, we see a huge dominance by, male gendered images. And so we see women dominating in 4 of these prompts, which could all be, seen to be feminine. So the 4 would be wearing makeup, looking after kids, nursing a patient, and wearing a dress. So that's just another interesting trend that we see through the action.
So here we have some of the examples of the prompts that we ran through the imaging model. And it's important to keep in mind that in total, we had around 100 prompts for which we generated 20 images, making about 2,000 images across our entire data set. It's also important to keep in mind that across the entire data set, around 70 to 80% of all of these images were tagged as white. So that's a signal that whenever you see a demographic that isn't white, that's the majority, that's a flag of some sort of inherent bias within the model. So starting off with playing basketball, we can see this is one of the few examples of African Americans making up a majority within a racial distribution, giving us a signal that within the training of the model, a large portion of the images fed while playing basketball had to do with African Americans. Once again, we can see through the prompt mopping the floor, this is once again reinforcing currently existing stereotypes of women being like expected to clean. Looking at things like doing math and going to school, we saw that whenever actions had to do with some sort of educational or academic outcomes, the majority of these actions ended up being the Asian demographic. So moving on to our occupations data set. Looking at CEO, for example, we can see these same stereotypes exhibited once again, where Asian and white are the primary demographics. And we can see that the difference between CEO and caretaker within the gender distribution is readily apparent. Within CEO, the majority of the images generated are male, whereas within caretaker, the majority of the images generated are women. And the last one is an interesting one, police officer, because it shows that despite the majority of police officers in the real world being white, the model for some reason is still exhibiting police officers as Black. So on to conclusions. Within the occupation data set itself, we found that higher salaries were often correlated to higher percents of being either white or male. Asians were more correlated to STEM-heavier engineering roles, and women were more correlated to nurturing or caring human interaction-focused roles, while men were often related to leading and technical roles. Within the action data set itself, we saw the same stereotypes exhibited. The traditional patriarchal stereotypes were exhibited across most of our prompts, like mopping the floor, and most of the leading roles were men, while assisting roles like paralegal, assistant, secretary, nurse were almost always women. So that kind of highlights an inherent training bias within our models, because as I explained before, 60% of copies in the real world are white, while only 18% are Black. But despite this, the model almost always generated police officers as African American, which tells us that the demographic that the model most closely relates to the word police officer just happens to be African American, which kind of highlights the training bias within these models.
One of the biggest limitations in our investigation was our sample size. Because each prompt had about a sample size of 20 images, 5% correlated to one image. In future investigations, we plan on conducting experiments with larger sample sizes containing about 50 images. Our investigation also explored two biases in society that, while important, are more broad. We plan on examining more nuanced biases, such as ableism, classism, colorism, ageism, and salary disparities to better understand where these biases develop in the real world and how they translate over to AI. The data we collected is further limited by the fact that we only examined Stable Diffusion XL. We hope to apply our methods to other diffusion-based models, such as DALL-E and Midjourney, and then conduct larger studies comparing the data we receive from the more diverse range of models. And finally, we hope to explore complex bias countering techniques and apply them to different phases of model training and training dataset creation. We would like to thank our mentors, Arjun Rajaram and Rithvik Vanga, for leading our team and providing us with the necessary resources to create a comprehensive paper on bias in text-to-image diffusion models. And we would also like to thank the staff of Blast AI for teaching us the fundamentals of machine learning, enabling us to understand this fascinating topic. Without any of them, none of this would have been possible.